Alright, so I've got it all put together now. I apologize for not video recording any of it. I knew it was going to be a lengthy process, and I don't really know if anyone out there really wants to see somebody put together an air compressor package, so I left it from that. You kind of saw the beginning of it, and now you got the finished product. So everything is complete. The only thing I haven't done yet is mounted the automatic tank drain. I'm going to take the one off the old Quincy tank, and I'm going to be smart this time. Rotary Comtech had made a comment on one of my videos, I think when I was installing the auto drain on the water separator. He saw how to take the I had to take the auto drain apart in order to spin it off, and he had made the comment, I kind of wished I would have maybe put a union in there, so I'm going to actually do that this time. So right now I've got a ball valve sticking off of a 12-inch nipple that runs from the elbow in the center of the tank, sticking out 12 inches. So it's just at the edge of the tank, and got a ball valve in the end there. I'm going to stick a short nipple in there, spin a union on there, and then another short nipple, and then the auto drain. So yeah, and that'll get wired into the bottom or the load side of the magnetic starter as well. So I played around with the RPM a little bit, and what I've noticed was, as far as recovery time, there wasn't a significant difference between a 1-inch larger pulley. The company I bought it from, when they build these, they run with a 7.5-inch pulley, which is like 600 or 767 RPMs. I tried the 7 3/4 pulley I had from the Quincy. You know, I think it was like 775 RPMs. Didn't see a real big difference in recovery, which I kind of suspected I wouldn't have anyways. But I know on the Quincy I saw a little bit more recovery than what I saw here. But regardless of that factor, it's ready to go here. I've got the belt guard mounted. I've got it plumbed in from the compressor to the tank. I've got a 4-way T here which holds the pressure gauge, pressure switch, and pop-off valve. And then to wire the pressure switch into the magnetic starter, I just used a chunk of SJOW 18 gauge wire. It's got 2 hots and a ground, so 2 conductors and a ground, I guess you'd call it. And same magnetic starter as I had on the Quincy, same motor I had on the Quincy, and I even took the Solberg filter off the Quincy and put it on here because the one that came with it, not really all excited about it, but you get what you pay for. So I have run it up and I've drained it down now, so right now they get to see real time. I know some of you might think it's kind of boring to watch an air compressor fill up. That's fine. If anything, I'll try to put a comment in the video to show where you can fast forward to get to like the end of the cycle here. So recovery time from 130 to this gauge reads 130 to 160. Yet this is the same pressure switch. And when this pressure switch was on the Quincy with a different gauge, the gauge read 140 to 170. So there's a 10-pound difference. I really don't know which is right or wrong. I mean, theoretically this one should have stayed the same, so it could be that this gauge is reading true or the other gauge in here is reading true. So it'll be good where it's at. If anything, I'll crank it up a little bit. But yeah, so we're going to give it a test run, and like I said, I'll put a time code up in the corner so you can see in real time how long this takes to pump up. I've also got did some clamp-on amp meter readings, and I don't think I ever got above 22 amps, and this motor is good for 23 amps, so I'm good there. So the motor, it'll be easier life on the motor. So alright, so I'm going to clamp this around one of the hot legs on the bottom. Here we go. it would really help if I were to close the ball valve on the side of the tank here. Alright, let's pump her up. So there we have it. We got 100 and just a little over 160 pounds, and you saw the time code on the screen there. You can see right when it kicked out, so within a couple milliseconds of the time code. But yeah, she's been warm. Crankcase is nice and cool. The one thing I noticed with this one especially, it'll help me in the winter time. Or it helped me in the summertime. It's going to kill me in the wintertime. I shouldn't say that. Depending on its use. This flywheel throws a lot of air because of the intercooler design. This one's got an intercooler on the side here, so it goes from the high pressure to low pressure through this loop here. So there's more open air fluid. It actually keeps the pump nice and cool, and it does a good job of cooling off the air between the two stages. But the reason I say that that'll kill me in the wintertime is right now the thermostat for the shop is on the other side where this is going. So usually this side of the shop is about 10 degrees cooler than over there. So usually when the furnace calls for heat, it's heating that side and forcing air over here. But the thermostat, like I said, is on that side, so it satisfies the thermostat. So if the amount of heat that this will throw off, it'll keep that room warmer and make this room cooler. But that's a different project. I'm actually looking at doing some hydronic heat. But regardless of here or there, that is the compressor. I will go and bleed off some air. Hopefully I can mute the volume, and we'll start right back up again and see what the recovery time is. So, like I said, I'll put a time code at the top. Actually, I will spare you. There we go. Pressure switch just clicked. So we are 130 psi. So, all right, here we go. So as I mentioned earlier, that this one uses a centrifugal motor, and that's what you heard bleed off towards the end here. There's a set of weights in here that open and close a valve by the works of centrifugal force. And in this elbow here, there's a couple little pilot holes. And when the compressor slows down, the weights close, and it lets off the excess air out of the head here. So it takes out of this little aftercooler here all the way up. Yes, there's a check valve in here, so it takes basically from the tube all the way up through the head. So that's a little different than the Quincy. Quincy, they don't use a check valve on the QR series. They strictly rely on the head pressure, and that seems to work for them, and it probably might work for these guys here too. But when I got this kit, I got everything I needed. So, and I do remember putting the check valve in there. The one change that was different from this model, from previous models, they used to take this signal line here from down below here in the check valve. The check valve actually has that 1/8 inch port on the side. I actually had to put a plug in there because now they've incorporated into this little aftercooler. So But yeah, I have to say I'm happy with what I got, and this one should last a while as well. And like I said, I'm not getting rid of the Quincy by any means. Obviously, the tank has a hole in it, which got me here in the first place. But I did pump this up before with a temporary belt on it up to 160 psi. I tried, giving it some time to let it settle. I didn't really see the gauge move, so I bled out some air down to about 140 pounds. I left, ran to town, got some new belts, took a chance on the belts, and they fit. And I came back, and the gauge was exactly where it was. Now on the Quincy, that was a different story. That would drop 5 pounds easily in a half hour, and I would kind of slowly taper off over there, and it would probably cycle once overnight. So I'm thinking that that tank, being it's got a pinhole now, it had a very, very tiny pinhole at the very beginning from day one. So it could be a manufacturer defect. Quincy doesn't make their own tanks. I don't think any compressor manufacturer makes their own tanks. It could be just a manufacturer defect from the manufacturer that they had bought from in that era. So, but yeah, so this is it. Probably the next video on this will just be the last update with it sitting in place. As far as that auto drain, like I said, I think I'm going to just hook it up over there because I don't want to risk breaking that nipple off on the bottom. So, and I have to do a little rerouting of the plumbing because now the port is over on this side versus before it was over here. So yeah, other than that, we're ready to go. So I'll probably do that this weekend. So that'll be another, probably shouldn't take as long as doing the other one because I do some major replumbing last time, but I didn't have to pull any wire because I'm using the same motor here, so I've already did that last round. So alright guys, thanks for watching. Questions and positive comments are welcome.